Hello, Challenger. Today we are here in another weekly live that happens every Tuesday at 10 p.m. London time. I'm very happy that today we're going to be talking about the feared coding interviews. I know they are hard to pass, but it's a matter of applying the right strategy and the right preparation, and then we can pass. The truth is that we need to be consistent in our studies, right? There is no easy way to pass on those interviews because algorithms is a skill that we need to improve. And it's a skill that we have to practice outside of our jobs because in our day-to-day jobs, we will be doing simple things, right? It would be doing or would be fixing some microservices, I don't know, endpoints, or it would be, doing more business related tasks. Obviously, it depends on the company you work for. So if you work for a company that has more technical products, then it would be different. Then it would be using algorithms maybe every day. But still, it's undeniable that learning algorithms for coding interviews makes you a better software engineer. So by practicing algorithms consistently, definitely you're going to become a much better software engineer. So I know that many of you find annoying that you have to learn algorithms for coding interviews, and you might feel annoyed because those algorithms doesn't really help you on your day-to-day job, but they will definitely make you a better software engineer. And also it will help you to pass in the interviews, right? Because without preparation, just forget it. You won't pass in the interview. Like it's going to be very difficult. The worst thing you can do is to prepare for those interviews in the interview, right? So it's the worst thing because the preparation is already hard. And if you want to get prepared under pressure when you are being interviewed, man, this is impossible, right? So it's better to prepare ahead of time so that you are ready during the interview and it's easier, right? And one concept you can use, and it's very related to the previous weekly live I did, is the concept of deliberate practice. What is that? It's basically your skill to practice something deliberately so that you get strategically better. It's not random practice, it's very strategic. And you can use that for absolutely everything. And that's amazing how we can improve any skill we want in life. And I thought in the past, oh, really, I can't improve skills that I am weak. But in reality, is that we can improve any skill we want as long as we practice whatever we want to improve deliberately. And if you want to know more information about that, you can watch the previous weekly live. But let's focus on the strategies for our coding interview, right? Okay, there are more people joining. Okay, hello, Igor. Hello, everyone. Very good. Okay, so regarding the interview, what is the foundation and the mindset? So the interview philosophy. So basically, when you're doing the interview, it's important that you communicate that you're solving the problem. So you communicate early and often. The worst thing you can do is to jump to the code straight away. Because if you do that, basically you are stating that you're not good problem solver, right? And during those interviews, there are some etiquettes to follow, let's say like that. So there are some rules that, like if you jump to the code straight away, they will immediately reject you because they'll say, oh, but you didn't even communicate how we would solve the problem. You didn't even plan. You just went straight away to the code. Yeah, there are some rules. If you don't follow those rules, you're going to fail. So we need to understand that the coding interview is just a game. It doesn't define you that, oh, you're a bad developer or you're a good developer. Obviously, like I said, the algorithm skills will definitely make you a better developer. But if you fail on those interviews, it doesn't mean anything, right? Because what really defines you as a good developer is your capacity to solve problems, right? And most times you don't need the algorithm's knowledge to solve our day-to-day job problems, right? But basically, we need to follow the rules. So for any game we are playing, and this goes to anything in our careers, in our lives. So we need to know how to play the game. Otherwise, we're gonna fail, right? Imagine if you are going to play a game like chess and you don't know the rules. How are you gonna even win? It's gonna be impossible, right? I know this is obvious, but this is something that, like, I see that many developers fail in those interviews and they take it personally. And it doesn't define you at all. It's just a game, and you have to prepare for this game. And you need to practice algorithms deliberately so that you get better. And also optimize for correctness first, then performance and edge cases. So basically, what this means is that you need to create code that is correct at first. No need to worry about making performance highly optimized, and don't need to think about all the edge cases. And it's very important that while you're doing this interview, it's important that you think out loud and expose the trade-offs, the decision process, and you need also to manage your time, right? So you need to divide the time into the time that you are understanding the problem, then you outline the problem. How can you outline? Literally, you just create some comments in the code. So you just create some comments, say, hey, first I'm going to create a for looping, and then I'm going to define this condition. And then in this way, I'm going to guess the output. Just do an outline, very simple thing, just to have a simple plan. You implement the solution, you test and optimize. And what is a practice strategy? I know that most of you are busy developers, and I would recommend to practice at least 30 to 60 minutes a day, right? And you need to do that deliberately, like I said. So you need to practice the algorithms that you are weak, right? And you don't need to solve the hard algorithms. If you solve the easy and the medium ones on LeetCode or HackerRank, this is usually enough. You don't need to solve the hard problems. Like, it's going to be a waste of time, right? And you also use the technique of deliberate feedback. So after each session, you can notice one or two improvements that you can practice again. And it's very important that you do mock interviews with peers or platforms. And by the way, if you want, in the Challenge Developer Mentorship, you can find developers to do as many mock interviews as you want, right? And okay, there is also a coding interview. So there are lots of topics here. Let's see. So what you should study for the coding interviews. So there is the core, it is structures and algorithms. So basically, you need to study arrays and strings. There are some strategies, some classic algorithm strategies here, such as two pointers, sliding window, prefix sums, hashing, map sets, duplication. So in Java, you can use hash set, for example, stacks and queues, right? There are trees, graphs, and you can use the depth first search or breadth first search. So it's important that you understand those algorithms, right? And you can use, you have to understand about heaps, priority queues, and binary search, patterns, dynamic programming, and greedy algorithm scheduling, sorting, partitioning. And if you're using Java, you have to know at least the basics of Java, right? It doesn't mean that you need to know like Java at certification level. You just need to know enough, just, to not do code atrocities, right? Code atrocities, concatenating 1 million strings, just using string builder or, would solve this problem. So regarding collections and generics, so you can use list, set, map, DQ, priority queue, and if you need comparator or comparable, we can use them as well. You need to understand, you need to understand boxing, auto boxing, and avoiding, unnecessary boxing. And like I said, it's better to use string builder rather than string concatenation to not create useless objects in the memory heap. And regarding concurrency, you need to know the basics of concurrency. Most times you won't need to do anything concurrent in an algorithm. But it's good to know some of the collections in Java that you can create thread safe code. IO and parsing, obviously, like most times you won't need to read information because the information is passed by parameter. But still, it's good to know about the scanner class or buffered reader, right? You need to know about the equals and hash code, contracts, and also pitfalls, right? So, for example, you need to know that the wrapper classes, they accept no, the primitive types, they don't accept no. So basic stuff. Honestly, like really, it doesn't really matter the language you choose, but still, I recommend you choosing the programming language that you feel more comfortable with. You don't make the mistake of, oh, just because I write less code with Python or JavaScript, I'm going to use those programming languages. That's a mistake because you're not used to those programming languages. Well, unless you are used to them, then it's fine. You use them. If you're not used to those programming languages, just use Java. Yes, you're gonna write more code, but you are a lot more used to Java, right? So Jonathan's saying here, HackerRank and CodeChef problems in some cases ask you to code the scanning part. Yeah, like in my opinion, this is kind of useless. Like read code should like doesn't make much sense because what matters is your problem solving skill. It's not like if you're able to read information. Yeah, that's kind of useless. Like I don't see the point. Like even like in Java, it's like it's I don't like to do to read data in Java because to need to instantiate scanner and you need to use lots of complicated methods. It's just scanner is that class that you almost never use in your life. But yeah, like, I don't like it. Regarding coding patterns and reusable templates, so you need to know the breadth first search and the depth first search templates, backtracking with pruning, sliding window, binary search, Dijkstra, so interval merging. And by the way, I'm gonna give you a book so that it helps you memorize all of those patterns so you can read them and implement them again until it becomes automatic. And we can also do testing and verification on the fly. And you can simulate small edge inputs. You can enumerate cases explicitly, right? And negative large numbers. And you can also print or reason on variance and loop invariance. So the invariant is basically the condition that keeps the algorithm going. You're going to see these keywords several times here in this presentation, and it's important as well to know about that. Clean code under pressure. So basically, you need to write, clear names. Don't write variables like with mysterious names like X or Z or Y. Name the variables in a way that it's understandable. Use small helper methods to make your code more understandable. And also avoid premature micro-optimizations. Write code correct first. That's the most important thing, right? And also avoid hidden mutations. So prefer passing value, like variables that won't be mutated in a method. And you can also comment complex sections with just very simple thing like a one-line comment. Okay, and how do you prepare for those interviews? So you can do a weekend deep work, and I know that the plan will vary from developer to developer because we have different routines, but this is just a rough plan, okay? It's not a plan for you because I know that it depends on your context, it depends on what is your routine, but the fact is that you need to be consistent to pass those interviews. You need to be consistent on your practice because really, and this is what I said in the previous weekly live, we actually learn a skill when we sleep. And this is very interesting. Like we only activate our long-term memory when we sleep. Therefore, when we are consistent and when we practice something daily, we grow exponentially higher. So this is very important to remember. Anyway, so this is just a key point. So weekend, deep work. So you solve 2 to 4 problems and you can have breaks. I love to use Pomodoro and all of my mentees also use it. and they love it. So, and Pomodoro is very good for productivity because then you know exactly how much time you've been dedicating to your goals, right? And if you have more time, you know, you can solve 2 to 3 easy problems a day. And, you know, you can also review the implementation or you can re-implement them, you know, because sometimes it takes like a couple of tries until you memorize the breadth first search or depth first search or the extra algorithm. So of those algorithms, it might take a while until you memorize them. I wouldn't say memorize, but fully understand them as well. So it's a mix about memorizing and fully understanding them. Because if you only memorize them, chances are that you're going to forget very easily. So we only keep the knowledge for the long term if we keep revising them for consecutive days, right? And also do at least one mock interview a week, right? And like I said, you can easily do that in the Challenger Developer Mentorship, and you can find many developers to do those mock interviews. And for a general tips, prefer correctness than optimize. Like I said, like it's important that you write the code correct first, and then you optimize because you know if at least your code is correct, if you're able to communicate and express yourself during the interview, the interviewer will like that a lot already. And then the bonus is if you can optimize the code, right? All of those things will definitely help, you know, and also state invariants and edge case scenarios before coding. So basically the rule here is that you never jump to the code immediately. You always ask questions, right? You ask questions, you make sure you understand the problem. You talk about the strategy you're going to use to solve the algorithm. You create a small plan and then you jump to the code. And like I said before, use string builder if you will concatenate strings. Okay. So like it's rare that you would create an algorithm that you have to do a thread safe algorithm. But if that's the case, like just use atomic collections, right? So basically those collections are thread safe and there won't be a data collision, right? So I always do an edge case checklist. So ask the interviewer for edge case scenarios. And if they tell you, hey, there is this edge case scenario, then you just, you know, create a validation for that. And I'll give you the cheat sheet, but how you can use it. So basically you can scheme the index before the interviews. You can re-implement them, re-implement the algorithms that you feel is the best for you to, you know, to remember. Also, add your own learning, right? So it's essential that you have a document where you have all your learning, you know, everything that's useful for you to solve those algorithms. Okay, so let's continue. Okay, and what is the problem solving framework? So like I said, when you're starting the interview, like you have to restate the problem, make sure you understand the inputs and outputs, constraints, edge case scenarios, and then you have to plan, right? Then you have to, you know, maybe create small comments with your plan. You define invariants, complexity target. You implement small composable methods, and you can create some fail fast checks. You optimize time space. You also discuss the trade-offs. And it's important that while you're doing the algorithm, you narrate what you are doing. And when you're practicing algorithms, I recommend you having a rubber duck. A rubber duck because it's a funny animal, right? It's the classic animal for programmers. It's the yellow rubber duck. And then you talk with this rubber duck. You explain the whole algorithm to the duck, right? If you don't have a duck, just get any object. But I recommend you getting the rubber duck because it is the classic animal developers use. So why not? Okay, so regarding core patterns and templates, well, and by the way, those are the patterns that, you know, it will be in the book. I will share with you in the end of this talk. Okay. So yeah, basically those are the patterns: 2 pointers, sliding window, binary search, graphs, artist paths, like Dijkstra, union find, intervals, backtracking, dynamic programming, strings, breadth first search. And the book is here. I will share that when we finish here. Okay, so for effective study, you can use HackerRank and you can time yourself because, you need to simulate this interview environment where you have this time pressure. And, it's important that you read as well about algorithms and you can definitely use AI. Use AI a lot so that you can really understand about those algorithms. And if you don't have a paid plan for AI, I recommend you all using like a tool on AI. And I personally like this tool here. So I'm going to send that to you on the chat. So why do I use this tool? So it's basically because I have access to all the AIs I want. So I can use Claude, I can use Grok, I can use ChatGPT, I can use what else? DeepSeek, I can use Copilot, whatever AI I want. Obviously, it needs to pay, but it's definitely worth it. It gives you the cyborg power, right? So we need to use the cyborg power. So otherwise, we're going to be behind, right? So, and what are the metrics to know that you are improving in 2 weeks? So basically, you're going to be doing them. You're going to be doing the algorithms faster and more easily. So you're going to notice that the more algorithms you do, like you're going to just look at the algorithm and you're going to know the pattern. You're going to say, okay, for this algorithm, I'm going to use this pattern. So it's going to be kind of automatic. Like the more algorithms you do, it's going to become second nature for you, right? And you're going to have fewer gotchas, right? Because your brain will learn different patterns and you're going to know how to solve them. Okay, for the first minute script, basically you restate the input and output and the goal. So basically, here you're confirming that you understand the problem. This is very important because sometimes, like if you don't restate the problem, it could be that, you start explaining the wrong thing. And, the very basic thing when you are analyzing a problem is to talk about the problem. So first you make sure that you understand about the problem and then you start solving it. The constraints, so you talk about the value ranges, the time and space target, edge case scenario. You ask the interviewer about the edge case scenario. If, you could receive no, or you could receive a very high number, those kind of things. And you can discuss about the patterns that you could use in this algorithm. And then you choose, the simplest approach first. So the simplest way that you're going to solve this algorithm. And you say the invariant aloud, right? And so basically you state that the condition so that the algorithm keeps going. You also outline before code. So which means that, you can create small methods or you can create small comments just to outline, just to have a small plan. And also if you have edge case scenarios, don't forget to validate those. Complexity check. So you're going to have to also state what is the complexity, right? What's the time complexity? Big O notation. State the trade-offs. Tell the interviewer why you chose this strategy, and if there was another strategy you could use, why you picked this one over the other. If you're using Java, just make sure that you're using Java properly, and for example, not concatenating like 100,000 strings. Like if you're concatenating them, just use string builder. And I also recommend to use flashcards. So there is a tool called Anki. I think it's an app that you can create those flashcards and you can review them as much as you want. And you can, time yourself doing those algorithms. There are some senior signals. So basically, it's the way you communicate, right? So you mentioned invariants and why they guarantee correctness. You talk about failure mode, state complexity, and scalability implications. You can talk about alternatives as well. So the more you do that, the more you're going to be considered senior. Like I said, like those interviews don't define you as a senior or as an intermediate or as a junior, but still, we need to play the game, right? And it's just how it is. It's just, the world is like that and we have to play the game. So most of the Java interviews, we're going to have to do those algorithms. Okay, what else? Thanks for sharing, Jonathan. Okay, so let's continue. And by the way, if you forgot, where is the book? The book is here. Core patterns and templates. The book is here. Okay, let me make it easier. So I'm gonna put the book here so that you can find it more easy. Okay. So when I finish this live, then I'll share you the mind map, and then you can download the book here, right? So it's easier for you to find it. Okay, so what is the practice strategy? So obviously this is a rough plan. Doesn't mean that it's gonna be the same for everyone here, but it's a decent plan. So day 1 and day 2, you can review arrays, strings, and some patterns such as 2-pointer, sliding window, hash maps. Day 3, you can do some algorithms with graphs using breadth first search, depth first search, and topo, then our shortest path. Day 4, you can use the patterns of intervals, sweep line, and heaps. And day 5, you can use dynamic programming, longest increasing subsequence, knapsack. So there are lots of patterns. And how you should perform on those interviews. So let's see here. So yeah, like we saw here, like we just saw, you need to communicate your thought process. That's very important. So that's why I highly encourage you to having a rubber duck and talking to the rubber duck, communicating your thought process, because that's a way for the interviewer to know your capacity to solve problems and also to measure your communication skills. So the more clear you can communicate your thought process, the more points you get for the interview. So you have to restate the problem using in your own words, have to confirm the inputs, outputs, constraints, and the examples. Ask for edge case scenarios, clarify performance. So if n goes to 100,000, so then you should aim for O log n so that you make the algorithm faster. And name candidate patterns. So for example, if you see that you could use sliding window, tell the interviewer. So talk about the invariants, trade-offs, choose the first solution. So always start with the simplest solution. So make it correct first, and then you optimize, right? Otherwise, you're going to waste time trying to make the most optimized solution. And it could be that you don't even finish the algorithm. And sometimes if you finish the algorithm and it's at least correct, you may pass the interview. Obviously, you gain more points if you optimize to the fullest, but if you at least solve the problem, and if you have good communication skills, if you communicate your thought process in a clear way, all of those things you get points, right? And outline first. So function, signature, base cases, data structures. You can create some small comments as well before writing the algorithm. You can talk about failure modes, and also keep it modular. What do I mean? Create helper methods for readability. Do some dry run. What is that? So basically you give an input in your mind and you debug the code in your mind, right? Doesn't mean that you're gonna literally debug the code, because in a coding interview, you usually don't have this possibility. You can't debug the code. In your home, yes, you can debug the code as much as you want, but during the interview, no. So it's important also that you practice this ability of doing dry run, basically to debug the code without using a debugging tool. So you debug the code in your mind, and you communicate your thought process. So you can even do that with the rubber duck. So you can say, hey, rubber duck, okay, in this iteration, I received the number 1, and the number 1 here gets assigned to this variable, blah, blah, blah. So check time, space, complexity, right? And you can use a brute force solution if you are out of ideas. Like you can also use the brute force solution. It's better than nothing. And it's very useful to know the patterns to solve the problems, because it's a lot, because then you can simply choose one of the patterns to solve them. So if you notice that the constraint is, very, very high, then you can jump to the optimized solution right away. Or you can simply ask the interviewer, ask, hey, do you want the most optimized solution? Like most of the times they don't want that. Most of the times they want you to communicate your thought process clearly and solve the problem. Doesn't need to be the most optimized way. And okay, so let's continue. And like I said, so what they evaluate that, you understand the problem and you communicate that clearly. You ask for the inputs and outputs, and the constraints. They want to see your fluency in the patterns and your ability to choose the right pattern for the right solution. Code quality, they want you to write good code, clean code. So where you name variables well, you name methods well, testing mindset so that you test for cases that can fail. You don't only test the happy path, and you think about the trade-offs, you articulate the alternative, the pros and cons. And this is a senior signal. The more you can communicate the trade-offs, the more they're gonna consider you. And yeah, make sure that you have your communication clear and concise. That's why when you're practicing algorithms, you need to talk with the rubber duck or with whatever object. And how can we study? You can do 45 to 60 minutes a day, and you can do 15 minutes review as well. That's important. A mock interview a week really helps. And you can implement 5 to 8 algorithms patterns so that you memorize and understand them. And on Sunday, you can just rest and do a light review. And this is the app I said, Anki Web. So you can use that for flashcards. And volume and pacing, you can do 10 to 14 problems a week. Doing 10 to 14 problems a week is much better than solving 50 problems in a rushed way where you don't review them, you don't learn very properly what was the solution, what was the patterns you used. So it's better to solve those problems and really learn the data structure, the patterns, rather than just doing lots of challenges but not learning anything. Then it doesn't make any sense. And the other thing that I highly recommend you is that, don't look at the solution right away. I would say that at least try 1 hour to solve the problem. If you can't solve the problem for more than 1 hour, then sure, go to AI, look for the answer, and, until you fully understand the algorithm. Because if you don't go through the struggling part, you won't learn anything. Because to learn a skill, to learn anything that's new, we need to go through this struggling period. Like there's no shortcut. You need to go through this struggling time so that you really learn, so that you actually learn the thing. Because if you try like 10 minutes and you say, oh, I can't, what's going to happen is that you're going to create a habit to give up very quickly in all the algorithms. And you can't do that. Like if you can't solve the algorithm in 10 minutes, you have to try at least 1 hour. Otherwise, you're going to train yourself to always follow the easy route. And when we are following the easy route, you're not growing. You're just creating an illusion, right? So you need to go through the struggling part. It doesn't mean that you need to get the most difficult algorithms and try them suddenly. Just start from the easy ones, like an RPG game. So an RPG game, you start with level 1 character and you start, killing with the weakest monsters. Like you start killing like a rat, right? And then it's very easy to kill a rat. And then you start leveling up. So do the same in real life. So get the easiest algorithm and then you level up bit by bit. Like you need to be patient, right? You need to have patience and consistency. You won't get good at the skill of algorithm if you think that you can learn everything in one day. That won't happen. It's impossible. If you think like that, you already fail. You need consistency. So you need consistency, patience, because this skill won't also happen like that overnight. It will take time. So keep that in mind. And so also, keep a gotchas log so that you have it all documented, right? And you're going to get, so those are the high yield topics. So what are them? 2 pointers, sliding window, binary search, graphs, breadth first search and depth first search, shortest paths, Dijkstra, intervals, merge, insert, knitting rules, sweep line, union, find, trees, and BST, dynamic programming. So those are the things that the more you practice, the more benefits you're gonna get. For these structures, learn how to use ArrayDQ, priority queue, hash map, and I know that most of you don't have 90 to 120 minutes, but if you can at least 1 hour a day, that's amazing. And if you can't 1 hour, do at least 25 minutes a day. That will definitely help you a lot. You can do flash review, and if you can solve one problem a day, that's better than solving nothing, right? Okay, what could be the other daily routine? So for busy developers, you can recite invariants, 5 invariants, and you can talk about trade-offs. You can implement the simplest correct solution. You can do some dry run with 2 or 3 edge case, and you can review some of the patterns, and you can add some information now in your gotcha log, right? And then you should practice the problems deliberately. So which means that you need to solve arrays and strings one day, graphs another day, intervals, heaps, shortest path the other day, Thursday. On Friday, dynamic programming. Saturday, you can do mixed review. You can just review all the algorithms you did. And Sunday, yeah, you can do kind of a lighter review on flashcards. And also remember the rule of simplest first. So if you're under pressure and you need to solve the algorithm, just, use the simplest solution. And to remember the communication style you use during the interview, basically restate the problem. So basically you say, hey, the input is the following, the output is this, the constraints are this, the edge cases are empty duplicates or negatives, blah, blah, blah. And then you talk about the key idea to solve the problem. And you can also do a dry run, basically running the program, running the algorithm in your mind, obviously. And then you also explain that to the interviewer. And okay, guys, so that's pretty much it. I'm gonna share with you here the form, the satisfaction form. So let me find here satisfaction form so that you can get this mind map. Okay, so let's see. So basically you can give feedback. Let me send that to you. Just a moment. So let me know when you're finished, when you're done. And in the meantime, I'll just talk about the important points of the interview. So basically, to pass this interview, like I said, you need to prepare. You need to be consistent on your studies. You need to practice all of the algorithms patterns. You need to know about data structures. You need to practice on LeetCode or HackerRank. And you need to expose yourself to different problems as much as possible. You need to practice those algorithms in a timed way. And you need to speak with an object. I recommend the rubber duck because it's the most common object we use as a developer, right? So you can speak to the rubber duck and you can explain your thought process. You can discuss, you can restate the problem of the algorithm. You can talk about the inputs and outputs. Then you can speak about the invariants you're going to use or the pattern you're going to use to solve the problem. You can also outline the problem. Like you can basically write a couple of comments to explain what you're going to do. And, while you're coding, do some dry runs, which means that you're going to run the code in your mind, but you're going to explain what is the output, what's going to happen. Basically, make sure that you're communicating it properly. The thing is that you need to practice. If you don't practice, it's going to be impossible. You need patience and don't have the mindset that, algorithms, it's useless for me. I had this mindset before, but the thing is that if you get really good with algorithm, you're going to become a better software engineer. Because when you know the fundamentals very well, you'll be able to create better code, more optimized code. You're going to be able to do a lot more, right? And when you use any collection in Java, for example, you're going to understand what happens behind the scenes. And you're going to learn how to create more optimized code as well. So it definitely makes you a better problem solver and a better software engineer in general. Because when you understand algorithms very deeply, well, I wouldn't even say very deeply, but you understand the fundamentals, the basics, you can change a programming language a lot more easily. So for example, if you have many microservices and you have many programming languages, like if you have Python, Golang, Kotlin, it's going to be a lot easier to change to other programming languages because you understand the fundamentals and you know that basically every programming language, they will implement the fundamentals. Very good. So guys, thank you so much for being here. Invest in your career. And if you didn't have time to fill out the form, copy the link and, you can do it after as well. And that's it, guys. I wish you a great week and I hope to see you again next Tuesday at 10 p.m. London time. I'll probably do a weekly live about system design. Okay. So I'm looking forward to seeing you there. And thank you so much. Cheers. Thank you.